All right, this video is just some extra practice graphing with the amplitude and period concept. So we'll talk a little more in detail, and you can decide if you need to watch the whole video, if you want to watch some of it, kind of up to you for what you need to practice. So we're going to start with this one. I'll take you through the whole thing. Remember, our amplitude is going to be talking about that vertical stretch of the absolute value of 1/2, which in this case will just be 1/2. I have no idea why there's a little eraser there, but we're just going to go with it. The period is going to be 2 pi divided by b. Well, there's our b value of 3. So 2 pi over 3. And our intervals then are going to be the period 2 pi over 3 divided by 4. Not 2 by 4. All right, well, fraction work, 2 pi over 3 divided by 4 would be the same thing as multiplying by 1/4. Do a little cleanup. 2 and 2. This is going to end up being pi over 6 that we're going to count by. All right, so still no vertical shift. Haven't studied that yet. Have no plus d value according to that generic function. My amplitude is 1/2, so I'm going to mark this as 1. We'll call this 1/2. That didn't really look like a half, but I meant for it to. Negative 1/2. No horizontal shift. I'm just going to start right here at 0, and I'm going to count this time by these pi over 6's. So there's 1 pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. 1, 2, 3, 4, 5 tick marks for my important 5 points of cosine. I magically ended counting by pi over 6's at 2 pi over 3. It's nice, and that all works out. So that was 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and 5 pi over 6, 6 pi over 6, 7 pi over 6, and 8 pi over 6. Another 2/3 pi away to get my next period. Undo that. Yep, took too much away. 4 pi over 3. All right, now the time to graph my cosine. So cosine starts at pi, highest amplitude, midline, lowest amplitude, the midline, highest amplitude. One rotation. High amplitude, cross that midline, low amplitude, cross that midline. High amplitude. I missed, but you get what I'm saying. Now, something that we learned in the last video is that this 3 should mean that I can complete 3 rotations in the time that I usually only have 2 pi, because this is a horizontal shrink of 3. So I'm pushing in this accordion graph, I'm shrinking it down. So if I keep going, if I go another 4 tick marks, so 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3. Did I lose track? We're counting by pi over 6's. My apologies. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, which is really just 2 pi. Look what happens with this next little loop. I now have completed my 3rd rotation in my normal 2 pi time. Now it's a little misleading because sometimes I mark, this amount of space and I call it pi over 2. Other times I mark this amount of space and call it pi over 6. But it's kind of like science class when you have a coordinate grid and you need to figure out how do you want to mark your intervals. It's up to you how you mark them on a graph, and so we're just marking according to this information so that things come out nicely for our 5 key points of what happens usually at 0, top of the circle, pi, bottom of the circle, and 2 pi. So this one I touched on at the very end of the video. I just want you to see this note again. Our theta here, right? Theta is our input. So all along the x-axis we have thetas, and then out comes, in this case, 1/2 of cosine of 3x, I guess. But in goes theta, out comes a trig value, right? We've looked at this before. Here, in goes theta, out comes a trig value. And you'll notice by the time we get to 6.28, which is really the same thing as 2 pi, we now have completed 3.14. 1, 2, 3, and a little bit more rotations. This is still lining up with our nice horizontal shrink going on. All right, back to the new stuff. So our amplitude, we have this kind of mess of a sine function. So I know it's going to look like this. And, I know this flip is actually going to mean it looks like the yellow one. So now I got to figure out the amplitude is the absolute value of A. Well, here's A. The absolute value of -5 is just 5. Because remember that negative sign gets taken care of when we talk about the flip. The period is going to be 2 pi over, here's B, pi over 3. So doing a little fraction work, this is going to be 2 pi over 3, which means it's really 2 pi times 3 over pi. Cancel. The period actually is just 6. So my intervals are going to be 6 over 4, which is really just 3/2 or 1.5 if you like decimals. Now, real quick, just so you can see this a little bit, pi over 3 times x is the same thing as what we have here. Just like if I had x over 2, that's the same thing as 1/2 x. Okay, so you want to see that as fractions so you can get this b value out of your equation a little bit sooner. Okay, so got that midline thing working. Haven't dealt with vertical shifts yet. They're coming, they're coming. And our amplitude, we're going 5 and -5 away because that's half the distance of the range. The range usually is -1 to 1. Now we've stretched it -5 to 5. My intervals this time, I'm going to start at 0 because I don't have a horizontal shift. Again, it's coming. This is 3/2. So this would be 6/2, which is really just 3. And then we get 9/2. And then we get 12/2, which is really just 6. Okay, and again, you'll notice 4 intervals got us to our period of 6. So this was 9/2, this was 12/2, this is 15/2. This will be 18/2, which is really just 9. This would be 21/2. This would be 24/2, which is really just 12. 6 away completes our next period. So I know that I'm done. I've counted 4 intervals over. All right, so in goes theta. Out comes a trig function, in this case, -5 sine of pi over 3x. We're going to start with our on the midline, but now I'm going to this lower value. So I go low because of the flip, on the midline, high value, on the midline. On the midline, low value, on the midline, high value, on the midline. Could I keep going? Sure. Could I have gone backwards? Important to notice is that we have our flip of sine. So we've got negative sine, the opposite of sine. We've reflected over the x-axis, right? We've flipped top to bottom, bottom to top. So we've got this rotation going on where we're flipping. Okay, think about that as a transformation. All right, last one. I'm actually going to see if you can find the amplitude, the period, and the intervals here and decide the general shape of your graph. So why don't you pause and challenge yourself to find those things and then come back and join me when you're ready. All right, our general shape is going to be the flip of cosine. So instead of starting up high, low value back up high, we're going to start low value, high value back down low. Our amplitude then is the absolute value of A, which is really just 2. Period is 2 pi over 2, which turns into 4. And our intervals is just going to be our period divided by 4. So we start with that midline every time. Still haven't had plus D. So we're right at 0. My amplitude is supposed to be 2, so 2 away, get that vertical stretch in there. My horizontal shift, didn't have one because we haven't dealt with the C value yet. Then I'm going to count 0, 1, 2, 3, 4, 5, 6, 7, 8. This is so nice. Remember, these are thetas, and this, in our case, is -2 cosine of pi over 2x. Okay? So let's think about graphing our flipped cosine. Usually cosine starts at its highest value at the first tick mark. Now we want to start at our lowest value, cross the midline, highest value, cross the midline, lowest value. lowest value, cross the midline, highest value, cross the midline, lowest value. Okay, now if I label more of these in between, this was 1, 2, 3, 4, 5, 6. Something I want you to notice from up here, this was pi over 2 times x, which is really 1.57 times x. Well, if I look, there's one rotation. There's another half of a rotation and a little bit more by the time I would have gotten to 6.28 or 2 pi. So remember, this tells you how many rotations you're going to get in the normal time of a cycle of 2 pi.